Hello everyone, welcome back to the tutorials again. So in previous session we have studied about the earth pressure at rest. So in which we have studied how to find out the lateral earth pressure, that is horizontal earth pressure, that is sigma h. So how to find out sigma h at a particular point we have studied. After that, how to find out the total earth pressure in a horizontal direction we have studied. So today we are going to study about the earth pressure theories, that is the Rankine's earth pressure theory. So these theories are developed to calculate the magnitude of lateral earth pressure. So, Rankine's earth pressure theory has various assumptions. So, the assumptions are as follows. The soil mass is semi-infinite and it is homogeneous. It is considered as dry. This is very important. The soil mass is considered as dry initially. But if the interference of water table is there, we have to consider that water table. But initially we are going to consider the soil mass as dry, and we are going to consider the soil mass as cohesion less. Okay, so cohesion less we have to consider initially. Next, ground surface is plane, so we are going to consider the ground surface as plane. There is no any slope for the ground surface. Initially we are going to consider the face of the wall is in contact with the backfill is vertical and it is smooth. This is very important. If there is any rough surfaces there, again we have to consider the friction between the soil and that rough surface. That is why we are going to consider the surface of the retaining wall as a smooth. The soil element is in the state of plastic equilibrium, means at the verge of failure, means uh, the soil element is having the maximum pressure which it can bear. After that, if the pressure increases, it is going to fail. So plastic equilibrium means it is at the verge of failure. So these are the various assumptions. You can split these assumptions to write in the examinations. So you can see if the soil, you can write soil is semi-infinite and homogeneous. Again, you can write soil is considered as a dry, and you can write the explanation. Similarly, you have to consider the soil mass is cohesion less. So like that, you can split and write in the examination. Next, you can see the active, uh, the Rankine's theory for active earth pressure. Active state of plastic equilibrium can be explained as follows. So what is the active state of plastic equilibrium? Whatever the pressure is there at the active state of plastic equilibrium, that pressure is called as active earth pressure. So that can be explained further. So what is the plastic equilibrium? What is at the verge of failure? What I am saying, what is that exactly? We are going to explain further, and after that we are going to do the small derivation to arrive to the formula. Okay, now let us study this. Let us consider an element of dry soil at the depth z. So same element, similarly, which we have considered element at the depth z, we are going to consider similarly over here. So which is at the depth z, as said, below the level of soil surface, so which is shown in figure number 1. Initially element is at the rest condition and horizontal pressure is given as, if the element is at rest, means if the earth pressure is at rest, horizontal earth pressure is k naught is equal to sigma v, means k naught is equal to vertical earth pressure. Now where sigma v is vertical stress at a point A, sigma h is horizontal stress at point A. So what is this point A? Point A is a point in on which point A is a point at the depth z. Point A is a point at a depth z from the surface of the soil. Now uh, you can see, we know that sigma v is equal to mu into z. It is fixed, we know about it. Means you can see the previous video lecture, I have explained it. Now stresses sigma h and sigma v are respectively major and minor principal stresses and indicated by the points A and B on Mohr circle. So Mohr circle represents the major and minor principal stresses, and it is also going to represent the principal stresses. About the Mohr circle, you have already studied in the uh, previous year. Okay, now sigma h is represented by point A, sigma v is represented by point B on the Mohr circle. So now you can see this is the Mohr circle. So Mohr circle, Morse has drawn the diagram sigma versus mu, mu on y-axis, sigma on x-axis. So point A represents the sigma, point A represents the sigma h, and point B represents the sigma v. So sigma h is equal to k naught into mu, we know. So this is the earth pressure at rest. These are the 2 points which I am marking. So let us forget about circle number 2, circle number 3. Let us forget about this. So let me explain about the Mohr circle. Mohr circle is a diagram which represents the failure envelope. Means this is the line. If the point falls on this particular line, how the point is going to fall on this particular line? If combination, the failure of any material is combination of stress as well as strain. Okay, or else I can call it as a normal stress and shear stress. So due to the normal and shear stress, the combination of these two is going to make the material fail. I'm just explaining briefly about the Mohr circle. So combination of these two stresses are going to make the material to fail. So if the combination, let us think that if the point is here, sigma is somewhere here and mu is somewhere here. So combination of these two are going to make the material fail. So if the point falls on this particular line, the material is going to fail. That is why it is called as failure envelope. Mohr circle is going to demonstrate about the failure envelope. Now on this Mohr circle, what we are drawing is, we are going to draw sigma v and sigma h, sigma v and sigma h. So first case, when the soil is at rest, I have drawn sigma v and sigma h. If the soil is at rest, soil is not going to fail. Now if I consider the active earth pressure, so in case of active earth pressure, what is going to happen? So let us consider this as a retaining wall. So this as a retaining wall, so it is retaining the earth, it is retaining the earth. If this retaining wall is going to move away due to the earth pressure, going to move away from the backfill, so here there is a backfill, so if it is going to move away from the backfill, then the pressure in this particular horizontal pressure, I am talking horizontal pressure in this particular soil, horizontal pressure in this particular soil is going to decrease. Why? Because it is as the retaining wall is moving away, it is releasing the space for the soil which is behind it. Okay, that is why the pressure will decrease. So horizontal pressure will decrease. So similarly, at one point, if the retaining wall has slightly moved, the A will shift from here to here, means A will shift from A to A dash. What is this A? A is nothing but sigma h. As the retaining wall is moving away, A is shifting towards the origin, because if the retaining wall is at the rest, sigma h is here. If the retaining wall will move little bit away from the backfill, sigma h is going to reduce. So you can see from here to here, second here to at this point, so it has reduced now. This is a second case. So now I should suppose this supposed to show this point here. I have drawn it here. So this is the second point, this is the second point, not this one, this is the second point. So sigma h has reduced. Similarly, if again the wall has slightly moved, this is second time the wall is moving, at that point the sigma h will move, come from this point to this point. As the sigma h is going to reduce, if the wall is moving away from the backfill, sigma h is going to reduce, means horizontal pressure on the wall is going to reduce, horizontal pressure on the wall is going to reduce. So from A dash to it come to A double dash. So now if I draw a Mohr circle, if I draw a Mohr circle by combining sigma h after moving the retaining wall, and sigma v, which is going to be constant. I am going to keep the vertical stress as a constant because height is not going to vary at all. So vertical stress sigma v will be depending upon the height, density into height. So height, this I am going to keep it as a constant. So if I draw Mohr circle by considering the movement of the retaining wall in an active case, at a certain point the Mohr circle is at this point, the Mohr circle is going to touch the failure envelope. So if this Mohr circle is going to touch the failure envelope, at that particular point is called as plastic equilibrium. So it is active case, that is why it is called as Rankine's active state of plastic equilibrium. So same thing I have written over here, whatever I have explained. So a to a dash it will move, the diameter of the circle will increase. So this you can see, a to a dash it has moved, diameter of circle increase, a dash to a double dash it has moved, diameter of the circle increase. So once it touches the maximum, so at that point it is at the verge of shear failure. So in this case, when the soil is at the verge of failure, Rankine's active state of plastic equilibrium it has reached, we can call. So it, a double dash is a point at which soil is at the verge of failure. So that is called as Rankine's active state of plastic equilibrium. The horizontal stress at this stage is called as active earth pressure. Whatever the horizontal stress uh, which is at this stage, which stage? Rankine's active state of plastic equilibrium stage. Whatever the horizontal stress is there, that is called as active earth pressure. Now you can see I'm going to only consider this half portion, and I am going to draw the points like this. So this is the origin C, and E is the point I am going to show at, for A double dash I am going to show the point as E, and by using a simple trigonometry I can derive the formula for PA. That is how I am going to derive the formula for PA, that is Ka into sigma V. So that is Ka into sigma V. So for Ka I can say that this is equal to Ka. So this is the Ka. So this is the Ka. Ka is equal to 1 minus sine phi divided by 1 plus sine phi. So I have just used the simple mathematical trigonometry thing to derive this. So you can just go through this by considering this triangle. I have derived it. So you can just go through it, and you can derive the formula for Ka. Okay. So after using Ka, Pa I can say it as Ka into sigma V. So Pa is equal to Ka into sigma V. That I have shown here. Pa is equal to Ka into sigma V, because Pa is nothing but it is the active earth pressure. So it is a active earth pressure, which is nothing but sigma H, that is horizontal earth pressure. So I know that sigma H is equal to Ka into sigma V, because I know that Ka is equal to sigma H divided by sigma V. Initially, if the earth pressure is at rest, I can call it this Ka as K naught. If the earth pressure is at active state, means if the wall is moving away from the backfill, I can call this I can call this coefficient as a Ka, that is coefficient of earth pressure and coefficient of active earth pressure, that is sigma H divided by sigma V. So from this I can say this, and from this I can uh, derive the equation for Ka. So Ka is equal to this equation I have got. So how I have got this I have explained. So briefly I have written the note in the notes, so you can just go through this, you will be able to understand all the things properly. Now, similarly, the passive case. So, in passive case, what is going to happen? All the things will remain same. All the things will remain same. Sigma V will also remain constant only. But in case of passive earth pressure, if let us consider this as a retaining wall. So, this is the horizontal earth pressure. So, in case of passive earth pressure, what is going to happen? The retaining wall will move towards the backfill. So if the retaining wall is going to move towards the backfill, the pressure in this backfill will increase, and similarly it is going to put the pressure, increased pressure on the retaining wall. So same thing I have shown here. So initially you can see sigma h is shown at by using the point A, sigma v is shown by using the point B. Same thing, everything is same again. Mohr circle I have considered. Now you can see as the retaining wall is going to move towards the backfill, I am talking about towards, if the retaining wall is going to move towards the backfill, pressure is going to increase. So sigma h is going to increase. So at one point sigma h will be greater than sigma v. At one point I am talking. So you can see it will go on increasing. So sigma h will once come here, it will go on increasing, it will once come here, it will be equal to sigma v will be equal to sigma h. Now at one point sigma at this point sigma h will be greater than sigma v. Now the diameter will go on increasing. At one point as the retaining wall is continuously moving towards the backfill, the pressure sigma horizontal pressure is continuously increasing. So at one point that is point A double dash, this Mohr circle which is drawn by reference points, that is major and minor axis, that is sigma h and sigma v, is going to touch the failure envelope. So at this particular point, we can say that uh, the stress at this particular point is called as passive earth pressure, and this particular point is called as Rankine's passive state of plastic equilibrium. Rankine's passive state of plastic equilibrium. Here it was Rankine's active state of passive plastic equilibrium. Rankine's active state of plastic equilibrium, but here it is Rankine's passive state of plastic equilibrium. So whatever the horizontal pressure is there at this particular point is called as passive earth pressure. Passive earth pressure. So same trigonometrical things I have used, and I have derived the equation for Kp. The coefficient in case of passive earth pressure is called as Kp. It is 1 plus sigma 1 plus sine phi divided by 1 minus sine phi, or else we can say it like this. So this is Kp and this is Ka. So Ka on the numerator minus is there, on the Kp, in case of Kp in the numerator plus is there. Okay, so further by using this Ka and Kp, we are going to analyze the active and passive earth pressures further. Okay, so after this I am going to demonstrate few of the cases, how to calculate the earth pressure in various cases. After that we are going to move to the problems. So today's class is very important. Just go through this class, and if you have any doubts, raise your queries. We are going to continue in next session. Thank you.